All right, when talking about multiplying polynomials, most textbooks and classes have a special section on what are called special forms. To me, it's not terribly important because if you just understand this basic concept right here, and then what'll happen after you've done like 200 or 300 of them, that's a joke, but what happens is you start recognizing some patterns. Now, all these patterns have to do with binomials whenever you multiply binomials. Okay, and that's the first one, and this one you may have heard of and remember. Okay, but the idea is that you have a binomial times a binomial. Okay, like that, and I mentioned this in my previous video. Okay, and so let's just look at an example here. Okay, so say I have 3x squared plus 4, and I go and I multiply that times 5x to the third plus 2. Okay, so remember what this general idea is, that anytime you're multiplying two polynomials together, you distribute each term of the first over the second. So to preview it, this is where this idea of what's called the FOIL method comes from, but I'm just not the biggest fan of using that phrase, and I'll show you in a minute. But anyway, just remember this basic concept that I just mentioned right here. So first I take that 3x squared and I multiply it by each term in the second. All right, and so what do I get there? I get 3x squared times 5x to the third, and then plus, plus 3x squared times 2. Okay, and so now I got my 3x squared distributed, so now I need to distribute that 4 over these two terms. And so then I'm going to have plus 4 times 5x to the third plus 4 times 2. Okay, now, so remember what we do now. We just have a bunch of monomials multiplied times each other. So multiply the coefficients, add the exponents. Plus 3 times 2 is 6, and then I have x squared. Okay, and then plus 4 times 5 is 20, x cubed. Remember, if there's no exponents to add, if there's just a single x term, it just stays the same. Okay, and then plus 4 times 2 is 8. We could write that as our answer. Now, very important, always look for like terms at the end, but there's no like terms right here. Typically, people like to write things where we go from the largest exponent down. This answer that I have written is technically correct, so you could stop there, but often we'll rewrite it where the x cubed term will be first before the x squared term. Okay, and so that would be the answer. Okay, so notice that we didn't talk anything about any kind of special form there. All we did is use that idea of distributing every term over the next. Okay, now in this special case where you have a binomial times a binomial, I've mentioned it before, people will often talk about what's called the FOIL method. All right, to me it adds on an extra layer, and it's very limiting in that it can only cover the case where you have a binomial times a binomial. Now I will tell you, in math that happens a lot, so you can learn it this way, but just you got to realize that this is limited to only this case right here. Now let me show you why they call it the FOIL method. All right, so why do they call this the FOIL method? It's just looking at a pattern that shows up, and it's just really a memorization technique. But to me, again, it's just easier to just remember to distribute every term here over every term here. But notice that whenever we did that, remember we did this double distribution. We distributed here, and we just distributed here. Okay, so the very first thing that we got is 3x squared and 5x times 5x cubed. Well, if you think about that, the 3x squared is the first term in the first binomial, and 5x cubed is the first term in the second binomial. So what we're saying is the first thing you should do is multiply the first terms, okay, like that. All right, and then if we look at this part right here, let me group that. Okay, now if we look at this, 3x squared times 2, well, with this kind of setup, notice that I have these two things and multiplied by these two things. So there's terms that are on the outside of this whole setup, and there's some terms on the inside of this whole setup. Okay, and if you notice that 3x squared times 2 would be the two things on the outside, and so people refer to those as the outside terms. Okay, like that. And just like I was just talking about, that 4 and that 5x cubed, those would be the inside terms. okay, like that. And then the 4 times 2, those are the last terms in each one of those parentheses. And so we refer to those as the last terms, okay, like that. And so if we just write down the first letter of each one of those phrases, that's where that phrase FOIL comes from. Okay, you don't have to know the FOIL method as long as you understand what we've been talking about before. But if it does help to simplify things, feel free to do that. Okay, I'm not saying you do. Also, if you're taking my class, you'll see problems from a book that tells you to explicitly use the FOIL method. That's up to you. All FOIL is doing this distribution. It's just a memorization device for doing this distribution that we've talked about. Okay, now this is a special form that's nice to be aware of, but again, all of these special forms that are in this video just rely on using distribution. Okay, now there's a phrase for this that I'll show you why in the answer why they call it this, but people call this next special form a difference of squares. Okay, and so look at my example here. I have 2x plus 3 times 2x minus 3. Okay, and so the thing is, that I basically have the same thing being multiplied by itself, except one of them has a plus and one of them has a minus. All right, and let me just show you. You can go through this just like we've been doing. You can distribute that 2x over these two, okay? And so I would have 2x times 2x, all right? And then I have minus 2x times 3. Remember that minus is coming from this minus right here. All right, like that. All right, and then I go and distribute my 3 like that, and so I get plus 3 times 2x, and then I have that minus, and then I have 3 times 3. All right, we go and simplify things out a little bit. Remember too, if an exponent's not written, that's a first power right there. So we're going to have 4x to the second by adding the exponents. All right, and then minus 3 times 2 is 6, and there's nothing to multiply that x by. And here's the key about the difference of two squares, is that we have 3 times 2x. This is positive 6x, like that, and then we have minus 9. All right, so notice right here, remember what I keep saying, look for like terms at the end. And notice these are like terms right here, but they're just opposites of each other. We have negative 6 plus 6. That's equal to 0. So this whole term right here just zeroes out, and I just end up with 4x squared minus 9. Okay, like that. So one thing here, even if you don't want to memorize the phrase difference of squares, the key thing is that if you're basically multiplying something by itself, but it only differs by the sign in the middle, what's going to end up happening is this middle term will subtract out, or these two middle terms will subtract out. Okay, but I am going to show you the formula for this. This is a nice one to be aware of. Okay, like that. Now, the key, why this is called a difference of two squares is if you think about the exponent laws, well, first of all, let's look at that 9. Where did that 9 come from? It came from doing 3 times 3. Another way to write that is 3 squared. Okay, like that. Now, where did that 4x squared come from? It came from multiplying 2x times 2x. All right, and so we could abbreviate that as 2x in parentheses squared. And just remember, whenever you square a product, you can distribute that exponent down on each one of those. Okay, like that. So, and then notice here, why are these two things significant? That's what was inside the parentheses of each one, like that. So if you recognize this form, if you recognize that you're basically multiplying by itself, but it only differs by the sign in the middle, you can shortcut this process by just squaring the first term and subtracting the square of the second term. I would advise practicing this out long a few times until you start recognizing that, though. In homework it'll probably be pretty easy because there will be a section on difference of squares, but in bigger practice these just show up in algebraic work, and so you want to be able to recognize them. Okay, but first of all, the way people will write this property is, notice up above we basically had two things multiplied by itself, okay, and the only thing is they differed by the sign in the middle. Okay, Now, it doesn't matter which order they come in, so you could have a difference and then a sum. The key thing is you have these two things that are the same, and you have these two things that are the same. The only thing that differs is the sign in the middle, okay? And the way you can abbreviate that property is the middle terms is subtract out, so all you have to do is square the first term, square the second term, and subtract like that. And that's called the difference of two squares formula, the difference of squares formula, okay? Now, like I say, this is something, it's a little bit more advanced. This one's fairly easy to spot, but not always, okay? So, as with everything in this video and in general, the way to multiply polynomials is just to distribute every term of the first over the second, and then you can just present what happens, okay? The nice thing about some of these formulas is if you happen to recognize it, then you can shortcut the process, but just be careful about overusing that and making sure if you're going to try to use one of those, you actually can. Okay, so now here's one that's very important. People always make mistakes with this. Okay, not always, but it's a very common mistake. And what the idea is that we have a binomial and we want to square it. So we say the square of a binomial. Okay, so here's an example right here. You might want to stop and think about what you would say is the answer. Maybe even pause, but I'll see this all the time, that this is equal to x squared plus 4 squared is 16. Okay, and I'm sorry to break it to you, but this is very incorrect, okay? And so, so be aware of that, okay? And I'll give you a little shortcut, or at least something to keep in mind. Anytime you square a binomial, you actually get 3 terms in your answer, and we'll see that. We're going to go through this. Okay, so what you're getting confused about, if you thought that's actually what goes on, is you were thinking that this exponent distributes. Okay, and we have seen a property where that does happen with one of the exponent laws. If you're multiplying and you have an exponent, then yes, you can distribute that on each one, and so 16x squared. Okay, but we're not multiplying here, we're adding, and I mentioned that in my video where I talked about the exponent laws. Okay, things that apply to multiplication and division typically don't also apply to addition and subtraction. So we can't distribute those exponents there, all right? And so that's not the way to do this problem. Let's think about how we would do it. You ask yourself, what does it mean to square something? The way to square something means to multiply it by itself. That, okay, and now we just have a binomial times a binomial, so I'll distribute that x over these two terms, and then I'll distribute the 4 over those two terms, all right? And so I get x times x plus x times 4 plus 4 times x plus 4 times 4. Okay, hopefully I didn't skip too much, but here I'm distributing the x, so x times x, and then x times 4, and then 4 times x, and then 4 times 4. Okay, now if you're not sure about what x times x is, remember anything times itself is a square. So this is equals x squared, but if you don't remember that, remember each one of these exponents are 1, so we would add the exponents. Okay, remember the order of multiplication doesn't matter, and we usually write coefficients in front of the variable, so I could rewrite that second term as 4x. Okay, now notice what's different this case, in this time. The 4's don't subtract out. We get the same thing. Okay, with the difference of 2 squares, we got opposites right here. But with squaring, we get the same thing. All right, and then we get plus 4 times 4, that's 16. Okay, the key thing is here, we have these like terms again. Okay, but 4x plus 4x, those don't become 0, that becomes plus 8x plus 16. Okay, so notice that we get 3 terms there. All right, now there is a formula for this, but this is like with the difference of 2 squares. As you're learning this, I would go through, especially with squaring, I would go through this process so you can see, and that'll get into your brain not to make this mistake right here. That to square something means to multiply it by itself. Also, you might end up sometime later in math, depending on where you go, you might have to square a trinomial or something even longer. In that case, the formula I'm about to show you doesn't even work, okay? But if we look at this answer here, this pattern is difficult to sink into your brain unless you're can really see it. But to square a binomial, let's look at our answer. The first part of our answer was x squared. Okay, that's just the square of the first term. Okay, the last part of our answer, or the last term of our answer, is 16. That's just the square of this. The key thing is to try to figure out what this thing is. And you can kind of see it from here. What happens is we multiplied these two things together, 4 and x, okay? But then we got two of them. They repeated like that. So I'm going to give you this formula, but again, I would be careful about trying to use it too much at the beginning. But the idea is that we're adding two things together and we're squaring that, okay? So just like we just saw, the first and the last term come from just squaring the terms in that binomial. So we have a squared and plus b squared, like that. Now the key thing is, how do we describe this term here? Like I said a minute ago, we need to multiply these two things together, but if we go through the whole process, we're going to get two of them, all right? And so what ends up happening is you add 2 times the product of a and b. Like I say, I would be careful about overusing that formula until you really understand it. So make sure you realize you don't need to know this formula. What you need to know is if you square something, you multiply it by itself, and then you just go through our usual process.